We will continue Maxwell distribution law of molecular velocities. Today we will find out the value of A and B constant. As in earlier classes, we derive an equation for number of molecules in between C and DC. This equation we finally found dnc equals to 4 pi n e cube exponential minus bc square c square dc. Now to find the value of a and b, we firstly differentiate this equation a from 0 to infinity, which means for all possible values of velocity. Now this can be written as this, but the standard integration equation is like this: for n barabar 2, I2 is equal to this. This can be written as directly, so put it in equation this, and finally we found if a cube is equals to under root b upon pi. This is the value of a. Now we find what is the value of b. Number of molecule per unit volume moving in x direction is given by this: fu du multiply by n. Since this is the probability as we had taught earlier, so this is given by equation first. Now pressure exerted by the molecule on the wall perpendicular to x axis, this is given by 2mu square. Since momentum change per collision is 2mu and number of molecules colliding per second is given by u. So finally we got this equation. The value of nu can be written from equation first. So we got this equation, and again we use this equation, this integration. So directly putting this value from here, and we got this: P is equals to mn upon 2b. P is the pressure. So as we all know, familiar with this equation for unit volume, P is equals to nkt. Putting this value here, we find nkt is equals to mn upon 2b. So b is equals to m upon 2 kb. Now we finally got the value of a and b. Now putting these values of a and b in equation a. In equation a means this, in this equation we got number of molecules in the range C and DC. dnc is equals to 4 pi n m upon 2 pi kt 3 by 2 exponential minus mc square upon 2 kt c square dc. This equation is called Maxwell law of velocity distribution. Maxwell law of velocity distribution. This equation shows the number of molecules per unit volume having velocities in between c and c plus dc. If we found if we found the probability of molecules which have velocity in between c and c plus dc, then we divide this velocity distribution dnc by c, then we can find the probability of molecules having velocities in between c and c plus dc. This equation represents the probability of molecules having velocity c and c plus dc